No. And of course I clicked on the wrong thing, but we're going to click on the right thing. And we're going to go back over here. I don't need this. Welcome back. We are MDEV1001, not 1004 like I said before, in the summer 2023 semester at Georgian, and it's week 2, part 2 of our broadcast and recording together. And we didn't do any of the theory last time. I just kind of went into like this setup thing that took us an hour and a bit. And why did I do that? Because I know you're going to need it for this week, next week, and the week after, and probably for a few weeks, right? And I want you guys to get comfortable doing it. Now, if there's something that's not working, remember you can uninstall. Anything that we've done, you can do it again. Uninstall everything, go back, reinstall it, and those kind of things. You can also try it on your PC. But PC, you have to download SQLite 3, because SQLite 3 does not exist by default on the PC, right? So if I was going to go here on a PC, and if I typed in command prompt SQLite 3, if I tried that out, so SQLite 3, this is on the PC side, it's going to go, burp, I don't know what you're talking about. It doesn't know anything about what I'm saying. SQLite 3 doesn't exist on a PC, right? So you'd have to download SQLite 3 and run it. You can run it as a service. There's lots of ways you can do this, but we're not on a PC, we're on a Mac, because that's what you're supposed to be on. So that's what we're doing. Okay. And where last we left off, we were talking about the stuff that we're doing today, and I talked about data modeling, and data models is what we're going to start with, and a bunch of other stuff. And then I started going into your setup. One other thing to set up that we're going to use is something called star UML. So please, let's download star UML together. Star UML, right? Star UML is a download, okay? And here's something that I want you to see. Does star UML allow you to download for Mac? Is there something like this for Mac? Or is it only for Windows? Huh? For Mac? Yeah, right? So let's try it out. If I was going to go into the Mac side, right? And if I was going to go here, and if I was going to go to I'm just going to make this full screen again, so it acts like my Mac is actually a real Mac, right? Then I can go here and go in. If I go star UML, and if I go here, then it should have download for iOS or Mac OS. Let's do this together now, okay? So download for Mac OS. It's going to ask me where do I want it. I'm going to put it in downloads. I'm going to click save. And then I'm going to run it. Let's see if it allows me to do such a thing. It says, let's take star UML and drag it into my application. So let's do that. So I'll take this and go like this, right? And then it's going to probably say, like, did it work for you, right? Doesn't do anything. Yeah, but let's see if it worked. So if I go into my applications now, right, because that's where I should have put it, applications, then what we're looking for is star UML, right, if it's here. So here is star UML app. And there's a little bit of a sign in front of it. What does this sign mean? So if I double click onto it, it says you can't open this application, star UML, because this application is not supported on this Mac. What? Huh? I feel angry, right? It's because my Mac is old, right? Your Mac is beautiful. My Mac is an old man. It has a cane when it walks, okay? That's how my Mac is. So that's why it doesn't work. Let me go and see, is there another version for people who have older Macs, is there a version of star UML that I can use? It says Apple ARM2. That's what it says, right? ARM64. That's why it didn't work, because there is no ARM64 version here. How about downloads? If I go to downloads, is there one that I can download here for the Mac? And it says that there's another one for Intel Macs. Oh, how do I delete the other one? You know, you're going to say to yourself, right? Because I need to delete the other one because I got this one. And that's a problem, isn't it? Right? Because, you know, I got this version, and I want to delete the one that I have. And let's make this so that we're going to go full screen here and not go full screen and just go up here. Well, one thing about Macs that are really interesting is you can just delete it. If I go here and I press delete, right, then I should be able just to remove it. So if I go like, file, and if I go, kind of remove or delete, I should be able to delete this. I should be able to send this whole app, right, to trash. That's what I can do. There it is. So that's gone, right? Let's try this again. So here's my Mac for Intel Macs, right? So I download the thing for Intel Macs. It tells me to put it in the same place. There it is. Save, right? This is for the Intel Macs. And then I open it up. Oh, look, there's no line through it. That's a good sign, okay, if you don't have a line. And if I drag it over, at home it's going to go make that sound, shh, right, which is probably like the right thing, or boing, or whatever it's going to be. Shh is the trash sound. And then if I go here and double click, it's going to give me this little, hopefully it'll work, and it's not going to do something weird like it did last time. Okay, so double tap. Let's try it out. And it's going to say, it's an app downloaded from the internet. Are you sure you want to open it? Yes, I'm sure. I'm that sure, right? It says buy now or evaluate. I'm going to click evaluate forever, right? No, I'm joking. I'm going to click evaluate right now. So this is the other thing we're going to need, because we want to be able to draw our diagrams, and Star UML is a free to try application that allows me to describe my models, right? So this is interesting because Star UML can do, it says Model Explorer, so I can create models with this, but it can also be used for UML diagrams, right? So I can add a diagram. You can see I can add a class diagram, right? And there's one that's an ER diagram that I'm allowed to do too, right? ER diagram is what we're going to do later on today. So this is what it does. If I click on add an ER diagram, it changes my schema here. That's a different schema. It changes my profile so it looks like I'm adding in an entity, right? And if I just drag or double click on the entity that I want to drag, you can see that I can start naming the entity. Like, for example, I might call it something like movies, right? And that's the movie entity. And then from there, what can I do? You can see that I have multiple entities here. I can, on the right, I can do things like delete. I should be able to delete the entity by right-clicking and deleting from the model. Right, I can do that. And if I go on the movie, you can see that from a properties perspective, it says that's the name of the entity, movies. Right, and what I can do is I can add a column, I can add a tag, right? Or I can add a flowchart diagram, but I can add a column, and I can add a column that says like movie ID, right? So kind of in there, and next to the column name is here. So down in here, I can add a column that says movie ID. Okay, and then in here for the type, right? It tells me some stuff like varchar or car, and what if it's a primary key? How do I add that, right? So one thing about Star UML is it's super well supported, right? So if I don't know how to do something, I can always look it up, right? So type is an integer. We know that my primary key is what is an integer type, right? We know that. Here's the length if I want to put it in here. I can click on primary key, right? I can say that if it's nullable or not, or if it's unique. And there's also ways of making it auto-incrementing it, right? That's what it does. So primary key, movie ID, integer. That's the movies table. Let's add another column to it. So I'll say add another column. And let's add this column, and this column is going to be called title. Okay, here's title. And then the type for the title. Well, we know if I pull it down that I use a char or car, and the length was 128, right? And it's not a primary key. It's not nullable. So nullable is unchecked, right? There's other ones too. There's like unique and those kind. We haven't talked about that yet, so I'm not going to add that in. And there it is. There's the next one. Isn't this wonderful? And you can kind of drag other things around. You can kill that entity, right? I'm going to right click and delete the entity, delete from the model, right? But take a look how this can work. It's kind of neat where I can click. Every time I click, I make another entity. Another table is what I'm doing, isn't it? Right? So that's what I'm doing here. And this is inside of my data model, right? This is inside my data model here, right? So the data model also can have a name, right? Which could be like the movie database. Or you could call this thing what do you want, which is ICE-DB, ICE2-DB, right? That's what the data model is called, right? And movies happens to be my movie table, my movies table, okay? So why am I showing you this? Because you guys are going to design your tables with something like this. You're going to create something called an ERD, an entity relationship diagram, right? Where you're only going to have one table in the entity relationship diagram for this week, right? And it's all the stuff that I wanted to add in. I want you to add in all the values here at the top for the short description and blah, 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 blah. And I want you to pick what the best type is. You decide, right? Because this is something that I want to accompany your actual database that you're going to put up on GitHub, right? You're going to create this diagram. One thing that you can see, which is kind of neat too, is if you go back here, right, for the this diagram, how do I save it? So if you say save as, what does it give you as an option? Well, it gives you an MDJ file, right? So that's something that you can actually save. You can save it as an MDJ file. You can save this file, right? Format is models, right? Okay, that's one thing you can do. What other things can you do? Let's make sure I don't click on that again. Delete. Let's uncheck this one. Because every time I check it, it means every time I go here, it does that. I don't want that. If you unclick this, if you click it, it'll actually do it every single time. Now, I should be able to click this diagram and move it around anywhere I want, right? And one thing you can see that there's lots of little controls here, like lots of controls in terms of alignment, line style. You can make it nice looking if you want, right? And you can do a lot of the additions here for column or tag or whatever you're going to do here, okay? That's one thing you can do. Other things you can also look at is tools. If you go to tools and if you go to extension manager, please, under extension manager, you can see that there is an entity relationship data generation, right? And it says ERD generation extension for star UML. Click install, please. And what this will do is it'll add the extension for the ERD entity relationship, diagram. And if I reload my model, and do I want to save my changes? Sure, let's save it. We'll save it somewhere for now. We're just going to call this in my documents. Let's put it where it's supposed to go. I'm actually going to put this diagram right now in that little drive I had it in. You can actually pull this down to decide where you want it. I'm just going to put it where I was just doing MDEV, that little folder that I had before. So if I just carefully go down there, you can go here and put it here. I'm going to call this, kind of like my ERD, we'll maybe call it ICE1 or ICE2, sorry, ICE2 underscore ERD, okay? There's other things you can do here too. It says Rebel. The Rebel is an advanced Java code generator. It enables modeling and code generation for Java Persistence API, Hibernate, Spring, Spring Data, and Jackson. So one thing that's a great thing about ERDs in general that we're going to learn about, or entity relationship models, ERM, right, is actually I can use them to code generate. It'll actually generate the connection and everything else. If you're going to connect to Azure or something else, there's a lot that you can be done here. But we're not going to do that, so we're just going to click Close. But why is this good, right? Because now, if I go to Model, right, so you see that I have, you can see UML standard model. There's tools, which you can see that there's a diagram generator, right? That's what it has here, diagram generator. And then there's maybe potentially other things that you can do here as well. Like, for example, I can do formatting. I can do a lot of other stuff here. And then I can even do, maybe it'll allow me to export. I can export fragment, or I can export a diagram as, and here's the beautiful thing, a PNG. And if you can save it as a PNG, I can click it as a PNG, right? I can open it up and I can see the diagram, right? So this is a beautiful thing. So if I try this out, if I say PNG, right, and I put it in the same place, ERD diagram 1 PNG, right? We'll just call it ERD. We'll say ICE1, we'll call it the same thing, just to show you this is part of what you're going to do. So if I say ICE2 underscore ERD PNG, and if I press save, it's going to save it as a PNG. And if I go into, I know you guys are dying, eh? Am I killing you already? If I go into the folder for this, so again, I'm going to go into, so for me, like I said, it's here, and you can see that these are up online. I can also eject these, right? So I don't need them anymore because I've already done my work. I've already done my installation. So I can eject those little installations. And for me, it's here under users, and under me, and under MDEV is where I have my stuff. This is me, right? So here's the PNG, and if I double click it, then we should be able to see this. And what's the problem with this? You get this unregistered stuff. I'm perfectly happy with it being unregistered. So if I see unregistered from you, it's not going to make me mad, all right? I don't expect you to buy anything or register anything. This is just for student use. So if someone's watching this video and you're like, Tom told them to use my stuff, and they're not paying for it, again, you're just using it because we want to learn. It's a free tool that anyone can use, Mac or PC, right? And we're using it so we can learn about modeling. And here you can see that we saw the data model in the background says unregistered because I'm getting you to save this thing, okay? Wonderful, all right. But there's other ways to do this as well. You could always take a screenshot, right? Which doesn't show unregistered. That's another thing you could do, right? Just FYI. If you want to make it look nice, take a screenshot. I mean, there's lots of stuff you can do. All right, so this model diagram is part of what we're going to be learning about today, all right? Star UML, we're going to use it for a couple of things this semester, and every time you have me as a prof. Okay, here's the things we're going to do with it. We're going to model our classes, because we can use this not just for entity relationship diagrams, ERDs, but we can also use them for making classes and objects. So if I want to describe code, this beautiful thing actually pumps out Java. So I'll do the Java code for you. I think it might even have a Kotlin plugin, no joke, right? And a bunch of other stuff, like just built in. So I think this is where it's pretty cool. It's like code generation from a visual. I can make an image, and all of a sudden it'll pump out some code. We can look at it later, all right? All right, we can close that down now. That was just an installation piece. So I remember told you this is like some installations we're doing today, all right? This is another piece of your installation. Questions around Star UML. Did everyone get it working, first of all? Hopefully everyone got it working. People online too. All right. Back to the real stuff today. All right, I want to talk about this piece. So now that we got Star UML downloaded and installed, and I showed you what to do with Visual Studio Code, hopefully you got that part done, or you're going to do it in the future. Let's talk about some stuff. So this is actually the piece that I want to discuss with you today, all right, which is all around data modeling. Let's talk about it. So we want to design a database. We want to make sure we want to structure it properly. And something called a problem domain is what we're looking at. We're going to solve a problem. We have data, we have information. We want to model it and create tables. More than one, chances are, okay? And there's some options to make this happen, okay? So again, what is a data model, right? It's a representation, usually something graphical, like we saw so far, right? And of something more complex. We want to simplify the complex thing that we're seeing, okay? I have some data, some information, and I want to represent it, so when I show it to you, you understand what it means. Think about what I'm trying to do is describe the table before I do one piece of code. Before I write a query, I define the table. Before I write two tables and the connections between them, I do the diagram first, okay? The diagramming that we were going to do is going to help us. If you pass an ERD to a database person, an entity relationship diagram, they should be able to look at it and go, I know exactly what to do. I know how to make this table 100%, because you've shown me all the columns and the relationships and everything else. So really the idea is for you to understand the complexities of the real world and relate them into something that we can see in the data, right? One thing that we want to think about data models, all data models, and there's different types that we're going to be talking about today, all right? And that I may quiz you on at some point. Like I said, I reserve the right to replace one of your in-class exercises or more with quizzes, like where actually you do multiple choice, true, false kind of stuff. And again, like I said before, if there's 4%, it's going to be at least probably 12 questions, a minimum. I can't make it any less because it's going to be too heavy. You miss one question and then your grade drops. I don't want that, right? So entities, attributes, relationships, and constraints. Entities, what are they, right? It's a person, place, or thing. That's what it is. Person, place, or thing, or an event, something that's happening, right? And how we're going to do that. An entity, it talks about some kind of type of object in the real world, and what we want to say is that we can distinguish it. We understand. It's something that we can understand what we're trying to do. For example, a customer, would have many distinguishable customer occurrences, such as Sam Singh. I made that name. I made that guy's name, eh? Sam Singh. He's a superhero. Pedro Patel, right? I made that name too. There is no Pedro Patel, right? And Jazz Carr, right? Jazz is a pretty cool person, right? She's pretty cool. John Smith, right? We know that guy, right? John Smith. And Mary Olson, random names that I've just randomly picked. I literally did a random name generator and picked John Smith. Woo! Entities may be physical objects as well, like customers, but they also can be abstractions like flight routes or musical concerts or something else, okay? Attributes are characteristics. And I took the same table I gave you, take a look at this table, and I said, like, these are all the attributes. One thing I also want to point out is this first line here, the first line, movie ID, title, it's kind of hard to see, studio, genre, all this kind of stuff. That is, if you put that whole line, that top, kind of like, line, if you will, the header row, that is your schema. That is your model, right? That represents what the table is going to look like. When we say model for you in your mind, you want to think schema. Model, schema to me are kind of interchangeable, right? It means, right, the model for the table, the schema for the table. It's just the way the properties are aligned, right, or the attributes. And typically what we have is some kind of key. We have multiple types of keys. We have a primary key. We might have a foreign key as well, okay? Primary key, there can only be one. It represents the rows for the table, right? Each row, which is a record, right? Each primary key it must be unique, okay? If it's not unique, it will be a problem, okay? Okay, so that's one thing that we're going to have. So that's our attributes for our table. Relationships. Oh yeah, we talked about this last week actually a little bit. We said there are one to many, many to many, and one to one, and they're represented by shorthand in a little way. For example, one to many is 1:m. Sometimes you might see in a diagram, not my diagram, I might give you a diagram, and it might show 1:m. It means one to many, right? Or 1 ... star. Dot 1 ... star means one to many, okay? So the notations here, I'm not going to read them all. Those are all the notations for one to many to or one to one, okay? And database designers usually use those things as noted above in their diagrams. That's what they do, okay? Let's talk about one to many. We talked about last week really quickly. Here's an example. A painter creates many different paintings, but each painted is painted by only one painter. Thus, the painter is the one, is related to the paintings, the many. One to many. One painter can make many paintings, okay? Therefore, database designers, they label the relationship painter paints painting. Notice it doesn't say paintings. It says painter paints painting, okay? And this idea, it's all capitalized. That's the convention. So you might see it like that in some kind of entity relationship model, an ERM, which is different than an entity relationship diagram, which is an ERD, which is what we were doing with star UML just a few minutes ago, okay? One to many. There's also many to many. Mostly we say M:(n) or star ... star, which is many to many. It's a many to many relationship. So we talked about this last week with students and classes, right? A student can have multiple classes and a class can have multiple students. Many to many relationship, right? And the other one is one to one, right? So here's an example. A retail company's management structure may require that each of its stores may be managed by a single employee, a manager, right? At the same time, that manager only manages one store, one to one, right? So that's the kind of stuff. Although in real life, a manager sometimes goes between stores, especially nowadays, because, things are as they are. Constraints, right? It's a restriction. A lot of times what it is, it gives boundaries. That's what it does for items inside of a database. Example, the rules for how we enter stuff in. And they have to make sense with the real world, right? Because if I don't give rules for the database, then your data could be invalid. Example, I added a date, and the date is from 1970. That doesn't make sense, right? How about the date is from 1800? That doesn't make sense. Or how about the date is, 2050? That doesn't make sense either, right? Maybe the date range is supposed to be between, last week and today, right? That's the boundary. That's your constraint for adding in the data. If you're scheduling something, you can't schedule something in the past. You got to schedule something in the future. So your boundary might be from today to maybe 30 days in the future. Maybe you don't want to give the person an opportunity to schedule, 2 years from now, right? Doesn't make sense. So boundaries, that's what constraints are to me. A GPA for the student can't be negative. You can't have a negative GPA, although some people should, right? Because some people are bad, right? Teachers should have a negative GPA too, the way I'm talking right now, right? But 0 to 4 makes sense. It's boundaries is what I'm saying, right? You guys are all good students. There's no negatives. There's no way you're going to get zeros, okay? Forget about that. You're going to get good GPAs because you guys are here with me, and I'm going to push you to have, perfect marks. Okay, perfect. 0 to 4, but for me, my GPAs are, 3.5 to 4. That's the boundaries. How about that? All right? And each class, I'm joking, each class must have one and only one teacher. That's not always true, actually. In real life, sometimes we co-teach, especially in the summertime. You might see some person teach you. The first half is one person, and the second half is someone else, right? So, boundaries, right? Constraints. Okay, next, business rules. This is something that was pounded into me when I was learning about databases way back in the day. Didn't understand what they meant by business rules. Why do I care about business rules? I'm not in business, right? That's not what this means. Business rules could be representing anything, right? It's real world rules with respect to what you want to accomplish here. What are you trying to model your data, right? And those business rules, your data has to make sense within those boundaries. So this is trying to bring the real world into the data side, right? Which is, if I want to model a movie database, then the data has to make sense. The stuff that I'm getting and the fields have to make sense with what the type of data that I want and how I want to analyze this data later on. That's what business rules pretty much mean. How is the data going to be used? When is it going to be used? Those kind of things. And really, it's not about. It's kind of weird. It's not about like the organization like as a business, but rather the organization as an entity itself, right? So how does that entity, if you're going to make a game, how will the game use the data? That's the business rules that we're talking about, okay? And really, we talk about things like policy, procedure, and principles. The relationship model. Okay, so the relational model is one of the first models that we talked about that were in the modern day. When I say modern day, like after 1970, okay? Before the 1970s, it was like, some kind of wartime, right? Wartime computers, right? Where we talked about cryptography and maybe AI and the Turing machine and a bunch of weird stuff. But after 1970, it's really funny, but the epic, the Unix epic is from like January 1st, 1970 for a good reason. A lot of things changed in 1970. And back in 1970, there's this guy, E.F. Codd of IBM, and he wrote this paper called A Relational Model of Data for Large Shared Data Banks, 1970, all right? And that's pretty much as old as I am. Sorry, let me say that again. Younger than me, right? And, really what this was, it was a huge breakthrough because it didn't use models that were hierarchical. It used models that were relational. They had the first way to relate one data table to the other. It happened back then in 1970, right? So a little bit of things. So we say that what is a relation? It's a mathematical concept, right? Where sometimes we call a relation a table, right? That's what a table is, a relation. And we think about it as a two-dimensional structure with rows and columns, where rows represent, sometimes they're called tuples, sometimes they're called records, right? And columns, a lot of times, are attributes. Sometimes we also call them properties, depending on which thing you're using it for, okay? So here's a relationship diagram, or a relational diagram. We just saw this just before, where we have a bunch of diagrams. Diagrams can be represented in different ways by different tools. The tool we were using, star UML, represented it horizontally. This is just representing it vertically, this way, right? And then what you can do is you can see that the relational diagram actually shows you the connection between the two tables. That's what it's showing you here. Agent and customer, those are the two tables. And it's showing you the relationship type of one to many. And see the relationship here is this infinity sign. Infinity sign is another way of indicating one to infinite, one to many, right? A one-to-many relationship. The entity relationship model came after. First, we had the relational model, and the relational model was the first kind of kick at the can. It was a one way of thinking about things. And then they made the entity relationship model, which is like, hey, we want to create things that are called entities, right? And what they did was they created this demand for relational database management systems, and this is kind of after. And these relationship management systems, database management systems, were complex. The reason why is because you got to think of what happened in the 1970s, guys, way back in the day. I know you're gonna get bored with history for a second, but you guys are students of computers, right? If you think about it in many ways. So think about the 1970s. What do we have in the 1970s? Do we have cell phones? No. We have fax machines? No. Did we have computers? Yes, but they were probably, for something that's on your watch or in your pocket, it's probably bigger than the size of this floor, right? Never mind the room. That's how big they were. They were massive and completely inefficient. Data banks, remember he said data banks? Data banks was like a bank of computers, basically a group of computers that were acting together in parallel, right? More than anything else, to give you like 4K of memory. K, not megs, K. It was huge, 1970. And they used punch cards. They didn't have any monitors of any type, and they had no keyboard. They had nothing. Input and output from computers back then were very, very slow, right? And it was massive. And people thought when they were in a computer room, first of all, it was hot, right? They had to cool it. They had to have a raised floor with all the cabling that ran underneath them. They cost millions of dollars for something that's in your pocket right now that might cost, $1,000, because the average person carries something like that, right? This thing costs millions. And millions back then was huge money. Like not million back then in 1970 is worth hundreds of millions now, right? So again, what it allows us to do is examine structures graphically, which is kind of a really huge jump again from relationships, right? So we had a relational model, and then we went to this. Once we went to the relational model, we can actually see things in graphic detail. Then the database designer was born more than anything else. That's when I think it happened, right? Where I can be a database designer and not write one speck of code, right? In fact, it's kind of the first part of the no-code, low-code generation and the revolution that's happening right now, right? How many softwares do you know about where you can drag and drop and all of a sudden some stuff happens, right? With you not writing a speck of code. Good example of this iOS. You guys are learning UIKit now, if I'm not wrong. Have you touched Storyboard and UIKit, right? Storyboard. drag and drop button, drag and drop label. What are you actually doing, right? When you drag and drop anything, in the back end, you have some kind of XML diagram, right? Or XML is what's happening, right? There's still code, you're just not doing anything with it. Same thing with Android. If you drag and drop something on Android, something is happening. There's an XML document that's being updated, right? You're not writing it, it's writing itself by you dragging and dropping it. Back in the day when they were writing these entity relationship models, it's kind of the same thing. They were designing things abstractly. Before actually writing any kind of commands, they were designing it. They were seeing how things fit together. It was the same thing with code. A lot of people do a lot of code this way nowadays, especially in enterprise, big, business, if you will, because if you and I start writing code and I just write, and I write in this direction, and you write over here in this direction, our code may not even link together properly. Or maybe I'm going to write this massive, monolithic class that maybe can be broken down into smaller classes, right? Designing it and seeing it in design is far more efficient than writing off the top of my head, right? It's not as good. So we have some notations, ERM notations, entity relationship model. I'm not going to go into details here. This is one of those parts where I said that we're out of scope. There's something called Chen notation after the person who created it, okay? And crow's foot notation. And there's also UML class diagram notation, which is the three types that we can see, okay? And what it does is it shows you different ways of representing the relationships between one table and another, right? That's what it kind of does. It talks about the relationships. Make sense? Stop me if you're not understanding, guys. So then we came to the point where we created something called, here's one, entity relationship diagrams. We want to have the entity relationship model, and we want a diagram for it. And again, like you see here, you have the name of the table, and inside of there you have different fields or properties that are inside the table. And you can see the connection between each of the tables and the type that you see. That's what these are, right? This is an entity relationship diagram. And this is something that you want to see. And it works well because what you can do is you can actually output to CSV, Excel databases, and a bunch of other stuff in more advanced systems. We're using a very primitive system, Star UML, right? But there's more advanced stuff out there that we're not going to touch because it's out of scope, that allows you actually to create everything. I'm talking about the entire table with data and everything and the connections too, okay? It's huge how much zero code you can do just by drawing diagrams, okay? UML class diagrams is kind of what we're going to go, and you can use class diagrams, especially when it comes to OOP type of data model, which we're going to see later on, right? And UML class diagrams look like this. One thing about UML class diagrams that you want to understand is that they mean something, all right? So at the top, I'm going to zoom in here so you can see the diagram. Let's take a look at the customer diagram. The customer diagram, if you look at UML, there are two parts to it. The top box, the customer, is the name of the class, right? And the second box is the name of all of its properties. The name, the type it is, string, and then address, and so on, right? As well as the relationship between this other table, which is the order table. So here's the order class or table. The order class has a 1 to many, it says 0 to many, right? 0 to many relationship, how many customers it might have, right? And it connects to this order. So customers can have 0 or more orders. But that makes sense. If I'm making an ordering system and my table is the order that I have, I might have a customer, but they might have 0 orders. That's also a relationship, by the way. We didn't talk about that one, right? Because until I have an order, it's not going to be in the database. It's not going to be in the table. A customer is still a customer, but may not have an order, right? 0 or more, right? And notice that the order itself has 3 parts to it as opposed to 2 parts. The top part is the name of the table, order. The second part is the properties. And the third part are the operations that it can perform. Or functions, if you're talking about classes. Okay, those are the 3 parts of a UML diagram. Hint, hint, if I was going to put that up on a test, I would ask you, label the 3 parts of the diagram. What are they, right? You should understand. When I draw something in a UML diagram, right, then you guys should understand what I'm drawing. With a UML diagram, I can describe code to you without coding. I can describe the relationship between 2 classes and the types of relationships they are. We'll go more into UML diagrams another day, all right? But I want to explain them today so that they're also another way of describing databases. It's another way of doing that. Then, after we went away from the entity relationship model, things progressed. Life continued to change. And object-oriented programming became super popular, right? Again, as of about 1990, so from 1970 to 1990, a lot of things changed. After 1990, we talked about last week that there are 23 design patterns, that OOP was on the rise, object-oriented programming, right? And there's different ways of doing things. And in 1990s and after, the object-oriented model started to gain ground, right? Because they wanted to describe things not just with database entities, but what are those model classes going to look like? You're going to learn, or if you haven't done it already, about MVC, Model View Controller, right? Where you have you're using a view controller right now with UIKit, right? UIKit, and if you drag and drop things into a storyboard, you see there's a view controller, right? That view controller, the name view controller, comes from Model View Controller, but actually Apple uses Model View Model, which is what it does. It uses an MVVM. That's not part of this class. We're moving on. But the idea is View Controller is what it's doing, and it's using an object-oriented approach, right, to doing its user interfaces. Well, that same object-oriented approach was so popular that they're like, wait, we can model our data class. Our model class is just a class that describes the schema of how this table looks like. That's what the data classes are, right? And so the object-oriented model grew out of that. Let's talk about emerging data models, things that you're going to see more and more that we're going to be talking about in this course. Big data. If you guys haven't heard about big data by now, at least the words big data, then you should. And big data was one of the biggest drivers of the NoSQL revolution, right? And what's happening now with MongoDB and Firebase and a bunch of other databases that are very popular to use with mobile applications, okay? Why? Because, we have a lot of structure, like we talked about last week. I'm just reviewing this with you. A lot of structure that we just talked about for making relational databases. Huge. I need a diagram. I need things to be in a certain order. There's a bunch of stuff that I need to do. And we're going to talk about some other things in a second too. Normalization and how much structure that entails, okay? So with normalization, I need to reduce repetition and that kind of stuff. Here, I want to be able to do things a little bit more unstructured. And when, outfits, social media came along, Facebook, Twitter, LinkedIn, and a bunch of other social media platforms that I haven't listed here, right? It needed unstructured data. If I want to make a post can have images or not. A post could have text or not. A post could have, emojis or whatever. And each of those posts, they're going to be saved somewhere in a database, right? Somewhere. So it kind of pushes this unstructured data. Same thing with mobile technologies, not just smartphones, but also things like GPS, RFID systems, weather sensors, biomedical devices, a bunch of stuff. It just continues to pump out this data, day in, day out. In fact, the amount of data being collected grows exponentially every single day, all right, which is really a scary concept. Where is this data being stored? According to IBM, this is this is about a few years ago where this little thing came from. It says every day we create 2.5 quintillion bytes of data. Quintillion, right? So much that 90% of the data in the world has been created in the last, it says 2 years alone. This was 3 years ago, all right, when this quote came from, right? So you got to think about the massive amounts of data that's out there, all right? Like there's just tons of data, right? And, this is one of the biggest challenges for organizations. Okay, we're in a school. We're at Georgian, right? And you have data on OneDrive, right? Each of you has data on OneDrive. Plus you have data, for email. Plus you have data on the learning management system. And that's just us. Think about every institution that's out there today. How many colleges and universities around the world have the same structure? And now multiply that, because we also have, businesses that have the exact same model. And you also have your own personal data. You might have OneDrive at home because you have a Microsoft account, right? So think about managing that type of data, all that data. Where is it going to be stored? How is it being analyzed? And so on, right? So we want to be able to manage it. And the need to do this, right, and to leverage all this stuff, this rapid data growth, performance, scalability, trying to lower costs and all this kind of stuff, has triggered something called big data. Big data is a huge field. There's actually a program here called Big Data at Georgian, right? It's all about big data, how to analyze it, and how to use machine learning, a bunch of stuff like that. And it's a huge field because, people are big data engineers out there. It's huge. So again, just to redefine this, big data refers to a movement to find a new and better way to manage large amounts of web and sensor-generated data. Okay, that's what it is. And while simultaneously providing high performance and scalability at a reasonable cost. How do I do that? Back in the 1970s, if they knew what we were doing today, they would blow their mind. They'd be like, oh my God, mind blown. Are you kidding me? Remember, Bill Gates once said, there's probably never going to be a need for everyone to have a computer at home. Bill Gates, right? And now everybody has a computer in their pocket, and pretty soon you're going to have a computer inside of your body somewhere, all right? We're going to see it coming. One thing is we want to talk about is just to end off this talk about big data is the basic characteristics of big data databases are the 3 V's: volume, velocity, and variety, right? Volume is how much, velocity is how fast it changes, and variety is the different types of data that are going to be stored in those databases. It's not contiguous. It's not structured sometimes. And so this gives the rise to this ability of, did I make a copy? I did. Of NoSQL databases. Let's get rid of that extra slide. I don't know what happened there. Again. NoSQL databases. So NoSQL databases was actually born out of the need, for big data, right? So we had things like, if you go to YouTube or Google Maps or whatever, or even Facebook, I don't know anyone who uses Facebook anymore, but if you're going to go there, everything uses NoSQL databases, right? And why? Because we have such a difference. Do we really need a relationship between one table and another? That's the question you should ask yourself. A lot of times for mobile devices, the answer is no. We don't need it, right? In fact, SQLite that we're going to learn first, local data with SQLite, is overkill in many cases for the thing that we need. Think about all the things we just did today with Visual Studio Code. We went this, we created a table, blah, 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 all these little queries. Do we really need that? Right? That's the question I'm going to ask you this course. And I want you guys to decide for yourself the type of data that you're going to use for your mobile device. And you might choose for you and your customer that there is no need for relationships, and therefore you'll never use SQLite. You'll always use some kind of Firebase or MongoDB or something out there that's NoSQL. So here's the difference between NoSQL when we talk about it. Again, we're going to talk more about NoSQL later on in the second half of this course. So they are not based on a relationship model, so that's why it's NoSQL. They support highly distributed database architectures, which means that I can have data centers around the world. I can have one in India, and I can have one in the continent of Africa somewhere, and I can have another one in South America, and one, maybe 2 or more in North America, right? And each of those data centers, they could distribute the data across all of those data centers to make it to reduce the latency of my request, so that if I'm closer to that data center, I get the data faster, okay? They provide high scalability, high availability, and fault tolerance. I'm not going to talk about that right now. We'll talk about it another time. And they support very large of sparse data that is not contiguous, that's not structured, okay? And of course, they are geared toward performance rather than transaction consistency. So it's not the same as the goal of structured data or relational data. It's not the same, okay? Here's the evolution of all those models. 1960, we had hierarchical. 1969, Okay, that's as old as me, right? We had a network type of database. And then 1970, we had relational database. 1976, we started talking about the entity relationship. And by the late 80s, early 90s, we started talking about object-oriented type. And finally now, after 2009, especially with the JavaScript revolution, with the Chrome V8 browser, right, that they came out, the V8 engine that they had for Chrome in 2007, right, they started thinking about NoSQL. Okay. Questions around the history. I had to tell you some of this. It's part of the course, right? You have to understand kind of where it all came from. And some words. So when we talk about things like entity relationship model, you should know what it means now. Entity relationship diagram, you should know what it is, right? Are you good? Can we continue? But did I bore you? I'm trying not to, I swear, right? I know this is some of this is dry stuff, right? But imagine reading it. It'd be crazy, right? It's better for it to be me telling you than reading it. Database tables and normalization. Again, we talked about this the very first day. We said normalization is the ability for us to remove data redundancy. And the table by itself is, in many ways, the basic building block of database design. Okay, that's what it is. And so ideally, the entity relationship modeling gives us good tables, okay? But sometimes it doesn't, right? Sometimes it's because the user, that's what it is. The user themselves, they don't know how to do things properly. Maybe they're not as, experienced in creating, data and stuff like that. And so we need to talk about normalization. So really what we want to do is be able to evaluate and correct table structures to minimize redundancies. By the way, the act of normalization is not automatic. It's not like you can click a button and all of a sudden it normalizes data. Sorry, let me take that back. It's not normally automatic, right? Nowadays it can be automatic, depending on the system you're using, right? You can look at a table and go split it up, right? And then it'll just do it for you, right? But the idea of normalization is what I want you to get, okay? Normalization involves assigning attributes to tables based on two concepts, determination and functional dependency, all right? Now, these are words. Let's talk about these words so you get them. Please don't be afraid of the words, right? What is determination? It refers to the relationship between attributes in a table, which means if I take different attributes in the table I showed you, this is the table that I have here, right? What's the relationship between the title and the studio? Is it dependence? Does it depend? Is there a dependency between the two? No. The title and the studio have no dependence, right? A studio can make any title it wants, okay? How about genre in the title? Is there some kind of interdependence or something like that? Yeah, there is, because the title has context and the genre follows the title. That's what it does, okay? Same thing with directors. Does the director and the studio have a relationship? They do, right? So even though, this is going back to the business rules piece, right? It's abstract. It's not something that you can look at and go, oh, I see. It's you knowing the business and you understanding the table and see if there's a relationship between the names you've chosen for the values of what you're putting in there, okay? Okay, back to this. So that's determination. And functional dependency is when we have kind of dependency between two attributes, right, within a table. One thing is depending upon another thing. One other thing we talked about, you might see in some of if you read some stuff about things, is something called determinate attributes. And these attributes determine values for other attributes. So you might have almost like A plus B, and A plus B is equal to C. So C is depending on A and B, because C's value comes from adding A and B together. A and B then are determinate properties inside of a table, okay? So normalization, it works through a series of stages called normal forms, right? And there are normally 3 stages, right, as described as first normal form, 1NF, second normal form, and third normal form. And really from a structural perspective, 2NF is better than 1NF, and 3NF is better than 2NF, which means the more we go down the rabbit hole. By the way, if you can get the fourth normal form, that's awesome. That's the lowest you want to go. All it means is that we have rules that discuss how the table conforms to this best practice. That's what this is. Think about normal forms as best practices. We want to do these things to reduce data redundancy, right? And there's some rules to follow to get to there, right? When you look at the rules. And here is the normalization process that I want you to follow for your in-class exercise 2, okay? Now, I don't need you to be perfect. I'm going to tell you this at the beginning. I do not want you to be perfect for your in-class exercise 2. I want you to try it out. I want you to think a little bit about this thing, okay? So here's the rules. Each relation, which is the table, represents a single subject. Okay, going back to this. Does this table relate to a single subject? Yes or no? Come on, guys. This is the table. This is my data. Does this relate to a single subject? Yes, it's movies. And never mind it's the movies, it's my 10 favorite movies of all time. All right? Just saying. And you can clearly see that I'm biased. I have science fiction and fantasy in my veins. Okay? That's what it is. But, so this is the thing. So this is what this table says. One table is all around movies. So it's a movie table. Now you can have a movie table that has thousands of movies, and that's fine, right? But it's the same stuff. Back to this. Number 2, each row, column, intersection contains only one value and not a group of values. Does my table comply? No. Why? Because it can't. Just like you said earlier, because my table has a bunch of values, a list inside of genres, directors, writers, and actors. It has a list, right? That's what it has in those places. So therefore, right now, my table does not conform to all those normalization steps right away because of that, right? Why? Duplication. Look, I have some actors that are listed more than once, right? Maybe I need an actors table, right? Maybe that's better. Maybe the actors table can show you the kind of the movies that are relation. Remember, just don't think about this as a table that's perfect. Think about this as a table of data that your customer gave you. And you're going to look at it and go, I see problems. Here are the problems you see. Duplicate data, multiple instances, or a list of, inside of a cell instead of a single value. If it's a single value, I can do data calculation and trends. I can do this kind of, I can count. I can't count so easily here. I have to use a formula to count, right? That's not what we want to do with a database management system. It doesn't take advantage of the database management system, right? Next, no data item will be unnecessarily stored in more than one table. Okay, that means like I'm storing the same data in multiple places. Why would I do that? Right? Some people do it. Okay? And all non-prime attributes in a relation table are dependent on the primary key. That means that when we say non-prime, we mean that if it's not another key, it's depending on the primary key, which means the primary key is an indicator of what this thing is about. Movie ID. Movie ID means that this is a unique movie, right? But actor ID has nothing to do with movie ID, right? Movie ID and actor ID are totally separate. They're not depending on each other, right? It's a little bit easier in this case. Each table has no insertion, update, or deletion anomalies, which ensures that the integrity and consistency of the data. This last point was, you don't have any garbage, is what this means. If you have garbage in the table, that's what this point is. Take the garbage out. Because if you have garbage in the table, garbage in, garbage out. You're going to see garbage in your database, on your app. Okay? That's a normalization process. And I want to zoom in here to talk about normal form a little bit. Okay, so here's first normal form. Table format, no repeating groups, and primary key is identified. We're almost there for first normal form, right? We just have to remove our lists, right? Second normal form, it's first normal form and no partial dependencies. What does no partial dependencies mean, right? And second normal form, third normal form is second normal form and no transitive dependencies. What does that mean? What does transitive dependencies mean? Let's go back out there and see what it means. I've actually defined them for you. So partial dependency. It occurs when a non-key attribute is functionally dependent from only a part of the primary key of a table, but might be dependent on another key. So example would be something like, I have orders and I have products. And I have an order ID and a product ID, right? And I have an order ID and a product ID in the same table, right? Two different IDs. If my table is called products and I have an order ID is a foreign key. And if I have an order depends on order ID. There's a dependency, but it has no dependence on product ID. Or does it? Maybe it has a partial dependence on product ID because the product is part of the order. See the thinking, right? So it's kind of confusing, and that's called a partial dependency. A transitive dependency occurs when an attribute depends on another attribute through a chain of dependencies, right? So where the value of one attribute determines the value of another attribute. That's what I talked about before. Product ID, product is dependent on product ID, right? There's a direct dependency on there. And you might have a chain of dependencies that are transitive. So if you have transitive and partial dependencies, you haven't met second and third normal form. Yes?
So the ideal situation would be, like in this example, to
Yes.
have like one product table,
Yes.
and one order table,
Yes.
primary key for
Yes.
product, one for
Yes.
order,
Yes.
and then
That's what it's talking about. That's what this whole thing, you got it. That's what it is. It's separating your tables. It tells you right there, partial dependencies and transitive dependencies can lead to data redundancy and anomalies. To resolve this issue and achieve a higher level of normalization, the table can be decomposed into separate tables. Now, let's go back to my problem, which is your in-class exercise for today, right? How do I decompose this thing into separate tables? What would I need to do? How can I take this data that the customer gave you and split it up? I want you to think about it, all right? You can discuss it amongst yourselves outside of the class, no problem. Think about the solution here. I've given you some data. There's only 10 records. But there's quite a bit of data here, actually, right? In 10 records. Think about the quintillion amounts of data that we get daily that are way bigger than this, all right? And then we're getting it every hour of every day, every second of every minute, right? We're getting data. Now, right now, as you're sitting down here, you're producing data that's going to the cloud because you're connecting through Wi-Fi. Every minute of every hour of every day, right? Where's that data going? And so I want you, one of the exercises that I want you to do, so here's your in-class exercise. I want you to recreate this table, right? I want you to do this, recreate this table, and I want you to do it with SQLite, okay? That's what I want you to do. I want you to try and think about normalizing. How do I normalize this table? Do I make another table, right? And I don't want you to think about the rules, or I don't want you to worry about being correct, all right? I don't want you to do that. I also want you to try, this is something I want you to do for homework on your own. It shouldn't take you more than an hour, okay? Is I want you to think about drawing this table out with star UML, all right? Draw the table. Complete the thing we started, right? Go through the star UML. And inside of your in-class exercise 2 GitHub repository that you're going to put up, you're going to make another folder inside the previous folder we made last week. Let's do it, right? So last week what we did was we made a folder on our desktop, no? Right. So here's our folder on our desktop called ISIS. I didn't do that today, and here's the second time we're going to see this thing. I want to add a new folder. Let's add one. So we can do it here. New folder. We're going to call this MDEV1001 M2023 ICE2. There's ICE2, right? And remember, we need to put something in there. So what I want to do with ICE2, this folder right here, right, is I want to, let's go back up one level. I want to go back to that Visual Studio Code stuff I was just doing, and I want to redo this part with you really quickly over the next 20 minutes. All right, here we go. Okay, we're going to go a little bit right to the end today again, 7 o'clock. I told you I have a lot to give you today, right? Here we go. Ready? And I need to do this because there's no good time. I can't do it next week, right? And I can't do it the week later because your assignment 1 is going to be due, and you need to do a bunch of other stuff with assignment 1, which I'm going to share with you later. So number 1, I want to kind of drag out this, kind of code right here. I want to take ICE2 and drag it into Visual Studio Code. Do I want to save it? I want to say don't save anything, and it's going to take us back to this. This is ICE2. ICE2 should be empty. Yeah. I want to bring up, it says git repository found in the parent on blah, blah, blah. It says, would you like to open the repository? And I'm going to say, sure, right? We can do it or ignore it. It doesn't really matter, right? But here, I want to bring up my terminal. So I'm going to go to, what I want to do is I want to go to here, this part. So this is my thing, and I want to bring up view, and I want to go terminal. So why, here's something, I'm having problems doing it. Why am I having problems doing it? How come I can't bring up a terminal here? It says open editors. Here's my open editor, right? So why am I having problems? Why can't I bring up a terminal right here? I can't do it with terminal. Doesn't allow me to do it. And it doesn't allow me to do it with view. How come that's happening? Well, one thing to do is, right? So here's the folder right here, right? So how come I can't do it here? Well, one thing to note is what's happening here. So remember that here's MDEV, and there's nothing in this folder. Let's try that again. Let's try that connection again. If I was to do the same thing with ICE1, here's ICE1. What are you seeing here? You're seeing this part, right? And if I go ICE2, here's ICE2. Again, if I go back, you can see that it's the same thing. It's like, it's going to give us this little thing here. So I want to run the terminal. Now I can do it. You can always try this out. Let's just say X. We're going to click this X down here when I ask you this question, right? So I want to go to terminal, and I want to go to new terminal. Okay, cool. Just like we did last time. So now I'm inside the exact folder. There's no navigating. Look, I'm in the exact folder. Let's do the SQLite command again. Here's the second time you're going to see it now. Ready? Let's do it together. It means you guys do it with me, right? So you can save some time later on. Ready? SQLite 3. / right? ICE3 DB. ICE2 DB. That'll be okay. And then press enter. Okay? And what we want to do is we want to create a table. So let's follow the creational table stuff that we did last time. So we're going to say in caps, create table, and then single quotes, the name of the table, movies, and then open bracket, right? Are you with me? This, you've seen it a couple times now. It's going to take you to the next part. We want to define our primary key, which is a unique identifier for the entire row, for all of our attributes. We're going to call this primary key the same as we have in the Excel database, right? Which is movie ID, okay? Movie ID. And the movie ID is going to be of type integer. You can make this in lowercase if you want, or uppercase, right? And then you want to define it as a primary key, and then it's auto increment, not null, comma, enter. That's the first part, right? So we're saying the movie ID table, or the movie table, movies table has movie ID, and that's the first primary key. The next one is, I'm not going to do all of them. You may have to redo this part, okay? You could remove the database that I'm giving you right now and finally finish this. This is for you to do. We're doing this together, but then you're going to do this by yourself, okay? So I want you to try this out. So you would go title next. Follow the thing I gave you. Title, studio, genre, director, writers, actors, year, length, short description. Keep going. MPA rating and critics rating. Those are all the things in the table. Why am I giving you something so complex? It's realistic. Because it's something that you may do, hint, hint, in an assignment. Like, hey, get your favorite movies and load it in, right? See what it looks like on your device. How do I make it look nice? How do I do all those things when I have all this data, right? Maybe I want to hide some stuff like the description unless I click onto it or whatever, right? That's why I'm getting you to do it. So title. Title's the next one. So I'm going to say title, right? And again, I'm saying it's probably going to be a char, but it's pretty long. Maybe you want to look at SQLite, the documentation online, and see what is the best data type. Remember, next week, I'm going to go through SQLite in detail. So if you don't get this right, it's okay. I want you to explore. That's what I'm looking for today. Explore as much as possible. So I'm going to use char, like we said, 128. And we're going to say it's not null, and then press comma. Then studio is the next one. And then, what's the other one? I don't even know. Genre. And notice like there's more than one genre. Okay, now this is not normalized. So this is not normalized form, okay? So I want you to try doing this out. So this is where I'm going to stop. I'm going to say that let's not go any more than studio, right? Because it's for you to do. Well, actually we have to because I put a comma in here. Let's just do genre next. Or, genre. Which is another char 128. I don't think char 128 is going to do it. Let's put char 255. Not null. It has to be in there. All right? And then let's just not put a comma here just for this version. You're going to do the real version. Okay? This is just my showing you what to do. This is the steps. Okay? Enter. And then semicolon. Close bracket, semicolon. Enter. It's going to make the table and make the database. Look how it appeared here. Right? In the Visual Studio Code. It's here, right? It's going to say, hey, are you sure you want to do this? This is binary. Do you want to open it? I'm going to say no. I'm showing you that it's here, though. Okay, good. Then what you can do is you can go here. Here's the connection stuff that we did last time, right? And I want to make a brand new connection. This is the old connection we had last time, okay? We can disconnect this one, okay? We can even delete it if we really want to, okay? I can delete this connection, okay? So if I right-click, and I can edit the connection or whatever. This is the first connection we made. Okay, that's what this is. So we can definitely try and, kind of delete the connection, right? So again, up in here, maybe you want to cut it or whatever, okay? But even if we don't, it doesn't really matter. Let's just make a brand new connection. So if you look here, it's kind of hard to see, but it's a little plus here, right? I want to add a new connection. I want to connect using SQLite. This is the thing that you've done before. It's going to ask you for the connection name. And we're going to call this connection name ICE2 connection, like we did last time. What if it's the same name? Is this going to go in the same place as the other stuff? Well, it remembered, right? Let's see if it works. And then let's see if I go select file. And this time, I don't want to go do this. I want to go to the right place, which is in my desktop. So I'm going to go to desktop. And I'm going to go to here. And then number 2, click on the connection file, click open, and then click save connection, right? And then I'm going to say connect now. And then you can see that one connection is active, this one, okay? And here's the connection, right? So let me just open this up so you can see this. Even if I have multiple connections, which I don't like, but I have multiple connections, only one is connected. The other one is disconnected. And you can see that this one may not be in the same space as this one, okay? So if I do, to check this out, if I want to open this up to check, you can see that this one has tables. Let me take a look here. Sorry, you were saying? The baby? Here, but this one has, both of them have movies in them, right? Both of them have moved, but one of them has movie ID, title, and studio. This is the way you can differentiate this, my friends. If you're in the same boat as me. And genre, and the other one, right, has movie ID, title, year, length. This is the older one that we did last time. We don't want this one. We want the one with the little dot next to it. See that one? That little dot indicates that we're connected to it, right? So again, I want to disconnect from this one, right? This one here. I want to disconnect from this one, right? And I only want to connect to the one that's where the one that I have, which is this one right here, the new one that I have with movie, title, and whatever, right? That's what I want. This is this connection here, right? And we can delete the connection when we're disconnected from it. If I'm disconnected from it, then I can delete it. So then I only have one connection, like I showed you right now, all right? It's pretty simple, straightforward. So now that I have this, let's add some data. And the way I added some data, and you're going to do this, is if I go to the table, which is the movies table here, you can see that there is a plus button. Sorry, you're not muted. I have to mute you. Okay. So then, right? So then if you look here in movies, right? Then what I can do is I can click on this button and I can add in, it'll start giving me some data. Again, guys, I don't want to do this. I've already did this earlier. I want you to add in that 10 parts of data. This stuff right here that I gave you, don't add everything, okay? It's too much. Let's add 2 pieces of data, the top 2 lines, because it's an in-class exercise. It's not supposed to be a killer exercise that's going to take you 10 hours to do. 2 lines, the first line and the second line. So Star Wars Episode 5 and The Matrix. Those are the 2 things you can add in, okay? Then see how it works. And then start thinking about normalizing, okay? So that's what I want you guys to do, right? And I want you to do this first database, and this database is not normalized. Add it in the way we have it here. Does it work? Try it out and show me in the video that you added in the database the exact same way. Just 2 lines is what I'm looking at. And every field is filled in, like the way I had it here, okay? Understand? Next, part two. The part that I want you to check next is the other part, which is I want you to draw this table out using UML, star UML, okay? And save a PNG file that I showed you to do. So in other words, save it inside of here. So if I go to here, you can see that I have in here, I have a ICE2DB and a .vs code with a settings.json. The settings.json is the connection to your database. That's what it is. That's what you get, okay? So you're going to put it here. And if I was going to do that really quickly, I'm sorry I'm taking long, I would go to star UML, I'd evaluate always, right? Just saying, right? And here, by default, this is the class model, all right? That's what this is. You can see what we did last time. We have some tools, right? We have a diagram generator, and we have a database if I want to, right? But I want to create a model. So what do I do last time for this? How do I do it? How did I do it last time? Do you guys remember? Right? If I go to model, then add what type of diagram? ERD, which is way down here, right? And then once I've done that, I want you to define the model. And then what I want you to do is after you've got the model, right? By the way, you can look up star UML. Star UML, there's plenty of information online on how to do it. Make a simple diagram. 1 table, 1 relation is what I want you to put together. With all the fields that I gave you, put them into star UML, right? Save the model or the diagram as a PNG. Okay, so in other words, you go File, and you go to Export, right? Or Export Diagram As, sorry, and you can save it as a PNG, right? And we can save it, I'll even save it the way it is so you can see it. This is the example diagram. And we're going to go into where it's supposed to go. So desktop, you're going to go into here, 2, and in here you're going to save this as the ERD diagram for in-class exercise 2. So ICE2 underscore ERD.png save. Okay? And then once you've done that, we don't have to save that right now. But once you've done that, now you have this other PNG. Right now my PNG is empty. I didn't do anything. Actually, it might just say, you know, if you click onto it, it'll say unregistered. I don't want you to do this. This is me. I'm showing you what it would look like if you put some other things in there. I want you to actually do the model. like all the fields in the model. Try your best, okay? Even if it's not perfect, just try and do it. Trust me. You'll learn from doing it, all right? Then put this up on GitHub. Let's do that right now. So terminal, I'm going to go to new terminal, and I'm going to go here and say something like git add dot. This adds everything to that we just added in. Git commit -m, and the first commit that I'm going to put in is added project files for ICE2, because that's what I just did. Enter. And you can see that those are the project files I added in, and now I'm going to git push. That's it, because you already have a connection. Git push. And it's going to take my stuff and put it up on GitHub. Please share the link with me again to make it easier for me to find. I don't want to go back to ICE1 to see your ICE2. It's the same link. You're not changing your link. The same link. But then I can go through and look at ICE2, right? And I can check to see what you've got. And if I looked at it, and if I look at it here on the Windows side, this is the last thing we're going to do. If I look on the Windows side, then I can go to GitHub, right? And if I look there, then yours should look like this, where you have ICE2DB and an ICE2ERD. That's what I'm looking for this week, okay? In the video, describe the process. Talk about, what you did to normalize. Is there a way you can normalize, okay? I'm not looking for a normalized database at this time for you to do it here physically. I want you to think about how you would normalize. Talk about it. How do I normalize this thing that Tom gave us, this monster? How do I do that? How do I change this? Do I make multiple tables? What do those tables look like? Do some research. Do some reading. Think about what this looks like, right? Because next week we're going to talk more about it, okay? Your assignment 1 is related to this. It's worth 5% of your final grade, right? And it's done in groups. For the final thing that I want you to do is, you may elect to do this on your own. You don't have to join, you don't have to be part of a group like an actual physical person. The group size is 2. You and one other person. Don't ask me for 3. It's 2, right? Where you and another person get together and you're doing pair programming, or if you want to talk about this as programming, right? Okay, and if you look at Blackboard, please look there. There is a groups link now that I put there. Please look at Blackboard now with me. Groups link, right? Under Blackboard, you can see that I have all these groups. A1 groups 1, A1 groups 10, A1 groups 11, okay? Join a group, even if you're a group of 1, okay? If you don't want to work with anybody else, you want to do this by yourself, you must join a group in order for you to do assignment 1. You cannot do this alone. You can't do this, you can't do this without joining a group, even if you're a group of 1. If you want to join with one other person, you can. Please don't join a random person. If someone joined you randomly, or you joined somebody else by accident, you let me know. I will remove them. They cannot join you randomly. They can just say like, Ramona, I'm with you now. Can't just do that, right? If Ramona invites me, she says, hey, you know what, Tom? Can we work together? And I say yes. Then we can join the group together. We choose the group, and then we join that group together, and that's our group for assignment 1 only. Assignment 2, there's going to be assignment 2 groups. Assignment 3, there's going to be assignment 3 groups, and so on. And for your midterm test and your final test, there will be a group for that, right? If I'm going to do groups, right? For assignments, make a new repository. 1 repository for your assignment. If you're working in a group, right, then it's 1 repository for 2 people. You need to know how to collaborate between each other, right? I will detail all this in the document that I'm going to share with you that I still owe you. I'm going to give it to you tonight. It's going to have all the details of what I want you to do. The assignment is going to be based on everything that we do in class. It's not going to be tricks. No tricks in the assignment. It's just going to take a little longer. That's why I need you to do a couple of weeks to put it together, okay? So it's things that we do in class. If you do your in-class exercise, assignments will be easy. If you do your in-class exercises, midterm tests will be easy. You'll be like, oh my God, is that all you need me to do? Yes, right? If you never do your in-class exercises, the midterm test will be impossible. It'll be like you won't be able to do it no matter how much time I give you. I can give you 100 years, you won't be able to do it. All right? Because we build one thing on top of the other. Every week we get together, we build until we get to the midterm test. That's how we do it. There's no tricks. I'm not doing tricks. You can get 100% on everything I give you if you follow along. If you don't follow along or if you miss a week, well, then you got to catch up, right? So assignment will be posted. Assignment right now just has a due date. That's all it has. And it's 2 weeks from now. June 4th. Sunday, June 4th is when the assignment is due, right? That's all it has. I will also provide a separate document that you can see whether you have the assignment or not. You won't be able to see this assignment until you join a group, even if it's a group of 1, okay? Questions around everything we've covered today. So, recap for ICE 2. Make a database with SQLite, command line, right? Add a couple of lines of my stuff, which is this stuff. Add these 2 lines here. Everything, add those things, all that data, add it into your database. Display your data, right? Like I showed you in the first part, all right? So that's using Visual Studio Code. If you're someone who's skilled with SQL, you could do a select statement if you really wanted to and write it manually, all right? And if you're not, don't worry about it because we're going to do it next week. We're going to do more about SQLite. If you're freaked out about this, you're like, I'm never going to get this. It's not true. We're going to do it again next week again. Don't be afraid, all right? I want you just to be hands-on and do this so that you're good. You understand what databases are all about. Make sense? Any questions or doubts? I know that you guys say doubts. Doubts? Any doubts? Okay, guys, thank you so much. That's it for today. Good luck with your in-class exercise 2. And if you have any questions, please ding me on Discord or email, before Friday. All right, thanks so much, guys. Remember that this weekend's long weekend. If you try and reach me on Friday, Saturday, Sunday, Monday, not going to be there. You're going to try and catch a fly with chopsticks. Good luck. Okay, thank you for that. So Elam says, do you have to, here's a question that I want to keep talking about. There is a question that came up. It says, do we have to implement normalization for ICE2? The answer is no. I want you to think about it and talk about it. All right? This is a non-normalized database. Okay? Same thing with UML. Don't think about normalization. Okay? Just do the UML diagram non-normalized. Okay? Any other questions?
I have a question.
Yeah.
So in that case, if we're not going with the normalization, does it mean we're going to skip the parts where we have more than one entry?
Yes.
When we're creating the database?
You can just keep it the way it is right now. I just want you to add in everything right now. And then next week, maybe I'll make you normalize it. Take the data and then think about how to normalize the database. However, if you're really ambitious, I'm going to put my hand up too and say, if you're super ambitious and you want to normalize early, like this week, you can. But I don't require it. I'm not requiring it. So if you want to do it, go ahead. But I don't require it. And I think it might be a good exercise for you to think about it because, hey, how do I split up this data? My customer gave me this data. How do I split it up? Do I put, actor IDs? Do I put like director IDs? Do I put in, genre ID, right? What do I do? How am I going to show this thing? Because what I really want to do is I want to only have one entry per, thing. How do I do that? And that's something we have to think about, okay? And you can get lots of examples, tons and tons of examples. Here's something you can try. ChatGPT, put in a few lines of your data and say, normalize this. Try it. It might be interesting. No, seriously. It might be interesting to see what you get. It might be wrong, too. Be careful, right? But try it out and see what happens. Okay, guys? I'm going to stop recording now. Any other questions before we go? Hopefully that's clear. Thank you so much. And good luck on your in-class exercise 2. Thank you for sticking around so long, and I appreciate the people that were here and online. As always, I really appreciate your time that you're spending